This is the beginner integral from dailyintegral.com, and you can see it's unique in that it has a summation term in the actual integral. So let's go ahead, because this is a pretty fun solve. So I already have the actual integral written out for you guys. The first thing I want to do is look at that sum more carefully. So I'm going to write out the first few terms of this sum. Alright, so I wrote down the first 4 terms here. So now what I want to look at is how this pattern that we see in this infinite geometric series will continue. To do that, we need to look at something called the common ratio. With the common ratio, we can rewrite the terms of any finite or infinite geometric series into this format. To find the common ratio, let's use this given formula. Now let's apply this formula to our own sum. We'll use the second and first terms of this infinite geometric series. Doing this yields our r, or our common ratio, to be sine squared x. We can use this format given here to check if our results match what the sum gives. Our starting value is 1, and our common ratio will be sine squared x. As we can see, our first 4 terms of this formula and the first 4 terms of our infinite geometric series are exactly the same. Now that we know the common ratio and our starting term, we can use a formula to solve this sum. That formula is given by this equation. Using this equation, we can rewrite our sum to look something like this. Now, we can make this claim. With this expression in mind, we can rewrite our integral and get rid of the sum altogether. Now that we've cleaned up the integral, we can continue. Looking at the denominator, we see that 1 minus sine squared x is actually a very important identity. It's the Pythagorean identity for cosine squared x. Knowing that, let's rewrite our integral once again. We can actually simplify this integral even further. We know that secant x is the reciprocal of cosine x. So, our new integral becomes, now this integral should just be a memorized antiderivative. All that's left is to use the fundamental theorem of calculus and determine our answer. Using the fundamental theorem of calculus, we can evaluate the integral to equal 1. Putting this into daily integral, we can see that this is correct. I would rate this integral's difficulty a 3 out of 10. There's no weird substitutions you have to make, and there's no integration by parts. But I did give it a 3 because it does test your summation knowledge and how well you know your trig.